Hello everyone, I am Darshan A, Assistant Professor of Mathematics. In the previous session, we have learnt about congruences and their properties. In this session, I am going to solve some problems on congruences. Let's get in. Consider the first problem. Prove that 6 divides n into n plus 1 into n plus 5 for every n belongs to Z. We have already solved this problem 2 times earlier in our sessions. First, when I discussed about division algorithm, I considered 6 different cases where n equal to 6k, 6k plus 1, 6k plus 2, 6k plus 3, 6k plus 4 or 6k plus 5, and later we have shown that this is always a product of 6 into some integer. And later when we learnt about properties of GCD, first I have shown that this is a multiple of 3 by considering 3 different cases, n equal to 3k, 3k plus 1 or 3k plus 2, and later proving that this is always an even number. 2 divides this product. Since 3 divides this product, 2 divides this product, and the fact that GCD of 2 and 3 is 1, 2 into 3 which is 6 divides this product. Here again I am considering the same problem. Here I am going to solve this problem using congruence. I considered the same problem because I wanted to make you realize that mathematics is the universal freedom that God has given to us. If you learn more and more of mathematics, you will find much easier method of solving the problems. Let us do it. Before solving this problem, we should know 2 things. First is A is congruent to 0 modulo n is same as saying that n divides a. In other words, to prove that 6 divides this product, we can show that this product is congruent to 0 modulo 6. And second, by division algorithm, we know that n can take 3 different forms: 3k, 3k plus 1 or 3k plus 2. This is same as telling that n is congruent to 0, 1 or 2 modulo 3. Okay. First I am going to consider case 1. If n is congruent to 0 modulo 3, in this case this product n into n plus 1 into n plus 5 is also congruent to 0 modulo 3. This is because 0 into anything is 0, so we get here this is congruent to 0 modulo 3. Next, in the case 2, if n is congruent to 1 modulo 3, in this case n into n plus 1 into n plus 5 is congruent to 1 into 1 plus 1 is 2 into 1 plus 5 is 6 modulo 3. Since 6 is a multiple of 3, this is congruent to 0 modulo 3. Okay. Now consider the final case. If n is congruent to 2 modulo 3, in this case the product n into n plus 1 into n plus 5 is congruent to 2 into 2 plus 1 is 3 into 2 plus 5 is 7 modulo 3, which is congruent to 0 modulo 3. Here we have 3 which is 0 modulo 3, therefore we get this is congruent to 0 modulo 3. Okay. In any case, we have n into n plus 1 into n plus 5 is always congruent to 0 modulo 3. In any case, we have n into n plus 1 into n plus 5 is congruent to 0 modulo 3 or 3 divides this product. Okay. Now this product, if n is even, this product is an even number. If n is odd, n plus 1 is even, so this product is again an even number. Now we have n into n plus 1 into n plus 5 is always an even number. This is because the fact that either n or n plus 1 should be an even number. This implies 2 divides this product. Okay. First, let us consider this as 1 and let us consider this as 2. Now, since the GCD of 2 and 3 is equal to 1, the product of 2 and 3 should divide this product. Since GCD of 2 and 3 is 1, 2 into 3, which is 6, should divide this product. Okay. Hence the proof. Consider the next problem. Show that m square is congruent to 0, 1 or 4 modulo 8 for every integer m. To prove this, let m belongs to z. Then we have 8 different cases. M is congruent to 0, 1, 2, 3, 4, 5, 6 or 7 modulo 8. Okay. Now if I consider m square, this implies m square is congruent to 0 square, which is congruent to 0 modulo 8, 1 square, which is 1, which is congruent to 1 modulo 8, 2 square is 4, therefore 2 square is congruent to 4 modulo 8, 2 square is congruent to 4 modulo 8, 3 square, which is 9, when I divide 9 by 8, I get the remainder as 1, therefore 3 square is congruent to 1 modulo 8. Similarly, if I consider 4 square, which is 16, is a multiple of 8, therefore 4 square is congruent to 0 modulo 8. 4 square is congruent to 0 modulo 8. 5 square, which is 25, when I divide 25 by 8, I get the remainder as 1, therefore 5 square is congruent to 1 modulo 8. And when I find out 6 square, we get 36. When I divide 36 by 8, I get the remainder as 4. 6 square is congruent to 4 modulo 8. And finally, when I find out 7 square, which is 49, when I divide 49 by 8, I get the remainder as 1. Because 48 is a multiple of 8, 49 minus 48, which is 1, therefore 7 square is congruent to 1 modulo 8. Okay. If you observe here, in any case we have m square is either congruent to 0 or 1 or 4 modulo 8, and therefore m square is congruent to 0, 1 or 4 modulo 8. Okay. Next, consider this problem. Find the remainder when 2 power 50 is divided by 7. Before solving this, we should know this. If a is congruent to r modulo n, where r is less than n and greater than or equal to 0, then r is in fact the remainder when a is divided by n. So here, to find out the remainder when 2 power 50 is divided by 7, we need to find out an x such that 2 power 50 is congruent to x modulo 7, where x is less than 7, greater than or equal to 0. First, let us start with the smaller power of 2, which is congruent to 1 or minus 1 modulo 7. By inspection, I can find that 2 cube, which is 8, is congruent to 1 modulo 7. If I observe here, when I divide 50 by 3, I get 16 as a quotient and the remainder as 2, so I can raise the power by 16. This implies 2 cube whole power 16 is congruent to 1 power 16 modulo 7. Here we get 2 power 48 is congruent to 1 modulo 7. Okay. But we need to get 2 power 50 here, so I multiply both sides by 2 square. So we get 2 square into 2 power 48 is congruent to 2 square into 1 modulo 7. So 2 power 50 is congruent to 2 square is 4, 4 into 1 is 4 modulo 7. Okay. Since 4 is less than 7, 4 is the remainder when 2 power 50 is divided by 7. Therefore, 4 is the remainder when 2 power 50 is divided by 7. Okay. Now consider the next problem. Find the last digit of 17 power 17. To solve this problem, I am going to use the fact that when an integer is divided by 10, the remainder will be the digit in the unit place. Any integer n can be written as 10k plus r, where r is less than 10 and greater than or equal to 0. So the remainder when an integer is divided by 10 should be the digit in the unit place. So to find out the last digit of 17 power 17, we need to find out 17 power 17 congruent to x modulo 10, where x is less than 10. First, let us start with 17, which is congruent to 7 modulo 10. When I divide 17 by 10, I get the remainder as 7. When I square on both the sides, I get 17 square, which is congruent to 7 square, which is 49 modulo 10. Okay. When I divide 49 by 10, the remainder is 9. So this implies 17 square is congruent to 9 modulo 10. But whenever we have modulo 10, we can add 10 or minus 10 as many times we need. So when I subtract 9 by 10, I get here minus 1, which is much simpler to handle rather than handling 9. So 70 square is congruent to 9 minus 10, which is minus 1 modulo 10. Okay. So this is the first step, as I explained earlier. First we need to find out a power of 17, which is congruent to 1 or minus 1 modulo 10, and later the things are simple. Now raise the power on both the sides, so we should get something nearer to 17 power 17. If I raise 17 square whole power 8, should be congruent to minus 1 power 8 modulo 10. This implies 17 power 16 is congruent to 1 modulo 10. If I multiply these two congruences, okay, 17 into 17 power 16 is 17 power 17, which is congruent to 7 into 1, which is 7 modulo 10. So the 7 is the last digit of the number 17 power 17. Therefore, 7 is the last digit. Okay. Now consider one more problem. Show that 53 power 103 plus 103 power 53 is divisible by 39. I have already told you that to show that n divides a, it is suffices to show that a is congruent to 0 modulo a. So here I am going to show that 53 power 103 plus 103 power 53 is congruent to 0 modulo 39. First I consider 53 power 103 modulo 39. Let us find out the remainder, and later we shall find out 103 power 53 modulo 39 and find the remainder. If we add those two remainders, we should get 0. First, we have 53 is congruent to 14 modulo 39, right? 53 minus 14 is 39, which is divisible by 39. So 53 is congruent to 14 modulo 39. When I square on both the sides, I get here 53 square is congruent to 196 modulo 39. Okay. So let us find out the remainder when 196 is divided by 39. When I divide 196 by 39, I get the remainder as 1. So 196 is congruent to 1 modulo 39. So we have 53 square is congruent to 1 modulo 39. Okay. Now let us raise the power on both the sides by 51. This implies 53 square whole power 51 is congruent to 1 power 51 modulo 39, or 53 power 102 is congruent to 1 modulo 39. Okay. Here we need to get 53 power 103, so I multiply these two congruences. This is 1, this is 2. From 1 and 2, we have 53 into 53 power 102, which is 53 power 103 is congruent to 14 into 1, which is 14 modulo 39. Let me take this as A. So next consider 103. Next 103 is congruent to, when I find the remainder, when 103 is divided by 39, I get 39 into 2 is 78, so the remainder is 25. Okay. So 103 is congruent to 25 modulo 39. If you are considering mod 39, we can add 39 or subtract 39, since 39 is 0 modulo 39. If I subtract by 39, I get here 103 is congruent to 25 minus 39, which is minus 14 mod 39. Okay. This is much simpler to handle rather than 25. When I square on both the sides, I get here 103 square is congruent to 196 modulo 39. We have seen that 196 when divided by 39 leaves the remainder 1. Therefore, 103 square is congruent to 1 modulo 39. Now to get here 103 power 53, I raise the power on both the sides by 103 whole power whole square whole power 26 is congruent to 1 power 26 mod 39. Okay. So we get here 103 power 52 is congruent to 1 mod 39. But here we should get 103 power 53. So I multiply these two congruents. Let me take this as 3 and this as 1. 4. This as 4. When I multiply these two congruents, I get from 3 and 4, 103 into 103 power 52, which is 103 power 53, is congruent to minus 14 into 1 is minus 14 modulo 39. Let us take this as B. Now we shall add these two congruents A and B. 53 power 103 plus 103 power 53 from A and B. 53 power 103 plus 103 power 53 will be congruent to 14 minus 14, which is equal to 0 modulo 39. So we have shown that 53 power 103 plus 103 power 53 is divisible by 39.